Okay. We'll edit that out later. I gotta remember how to set up on the Mac to it records the mic and the audio at the same time, and it always screws things up. This is an example from 5.1. And so this is example 5.1 out of your textbook. And let me just read what the textbook says. Well, maybe I'll just put it on the screen and we can read it together out of the book. What we have here is it says that a student holds her 1.5 kilogram psychology textbook out the second story dorm window until her arm is tired. Then she releases the textbook. So she's throwing her books out the window. No. I realize that my classroom is on the second floor, and no, it's not an experiment. We're not doing a lab. Be quiet, pay attention. So what we're asked to do is figure out how much work is done on the book by the student by simply holding it out the window. And then part B is how much work is done by the force of gravity during the time the book falls, and it says 3 meters. So let's set this up, all right? So she's in a building, all right, and she's got her hand, and here is the little book. And it said that the total displacement is equal to 3 meters, all right? And it tells us that the book weighs, or doesn't weigh, it has a mass of 1.5 kilograms. Okay? And we want to know how much work has been done by gravity. Well, how much work is she doing in the beginning? So there's a part A and a part B. Part A is how much work is she doing by holding the book in place? Well, here's the thing. Is she's holding the book in place, the amount of work that she's doing is what? Well, remember that work is force times displacement. Well, if she's holding it in place, what's the displacement? 0. So the force of gravity pulls on the book and she opposes the force, but since the displacement is 0, we have the force times 0, which is just 0. So part A is easy. She's doing 0 work. Okay. Now part B is a little more complicated. Part B wants to know how much work is being done by gravity if it is displaced 3 meters. So what we need to do is we see that the work is equal to the force times the displacement. And we see that the displacement is 3 meters. So what do we need to calculate? The force due to gravity. Well, now the force due to gravity is kind of a simple thing that we can calculate, I think. Force is equal to the mass of the object times the acceleration. Now, if the force is due to gravity, that would be the mass of the object, which is 1.5 kilograms, times the acceleration of the object, and the acceleration due to gravity is 9.8 meters per second squared. So then the force that we've calculated is 1.5 times 9.8. Let's pull up a fancy calculator. And I hope I can remember where I put this thing. I think it's right here at graphing calculator, or is it calculator? I think it's just calculator.
Oh wait, Mr. Adams. I just remembered I have to go sell those things.
Okay, go ahead. So I have graphing calculator 1 and graphing calculator. Okay, so this is the one that I was looking at. So if I say 1.5 times 9.8, oh, I don't want functions. Oh, that's the graphing calculator. I'm sorry, I pulled up the wrong one. So we just want to do basic math. So I'm going to say 1.5 times 9.8. And it's 14.7. So what I have here, guys, is this is 14.7 newtons. So what I'm going to do is to calculate the work, my work is going to be equal to 14.7 times the displacement, which is 3. And we know that the unit for work is joules. So now I need to do my calculator again. And we're going to evaluate that times 3 meters displacement. So if I evaluate that, I get 44.1. Is that right? Well, what is the SI unit for work? Joules. You guys see how I did that?
Yes.
Okay, that's that question.